This is the second part of our lesson on multiplying powers, and we just learned that when you are multiplying two powers together that have the same base, you leave the base the same and you add their exponents. But the thing that we need to talk about is what happens if you have coefficients in front of your powers. So this one here, I have 5x to the power of 3 times 4x to the power of 7. So when I look at this, the x's have the same base, right? X to the 3, x to the 7, they have the same base. 5 and 4 are not the same base. So if I were to rewrite this in a different order, I would say this is 5 times 4 times x to the 3 times x to the 7. So it still has all the same parts, right? We're still multiplying. 5 times x to the 3, 5 times x to the 3, 4 times x to the 7, 4 times x to the 7. I just rearranged them in a different order. So because these x's have the same base, I can use an exponent law on those and do x to the 3 plus 7, which is x to the power of 10. But the numbers in front, I cannot use exponent laws. So I could just leave it as 5 times 4 times x to the power of 10, but that seems silly to me. If you have a coefficient, and a coefficient is a number in front of a variable, right? It's not going to have an exponent. It's going to be just a number sitting in front. If it's like this question up here, right, where the exponent is on the number, that means this is a base. We don't touch the base. But if there isn't an exponent on it and it's just a number hanging out in front, they're fair game and we can multiply them. So I would do 5 times 4 is 20. So this is going to be the same thing as 20x to the power of 10. Now I'm going to be honest with you. You are going to get mixed up, right? You are going to forget when you're supposed to multiply these and when you're supposed to use exponent laws, but I'm going to try to remind you as much as I can. So you need to always be asking yourself, is that number a base, right? Does it have an exponent on it? Should I use exponent laws? Or is it just a coefficient that I can multiply with another coefficient? So if I take a look at the next one, 10x times 2x to the 4. So I notice I have two different terms with x's, and I have two coefficients. How do I know those are coefficients? They don't have an exponent, and they're in front of a variable. So I am going to simply multiply the 10 and the 2 together to get 20. And then I'm going to do x times x to the 4. Now, because they have the same base, I can use exponent laws. Now, that x, that first one, is secretly x to the power of 1. So if you don't see an exponent, it's always a 1. So x to the power of 1 times x to the power of 4 means this is x to the power of 1 plus 4. So for the ones that were bases that had exponents, because they were the same base, I used the exponent law. When I had the 10 and the 2, they were not the same base. They didn't have exponents, so I just multiplied them together. Now when I say they don't have exponents, everything has an exponent of 1, but we don't worry about it. It doesn't have a visible exponent for us to worry about. So this is just 20x to the power of 5. All right, our last one, I have 6, a to the 3, b to the 2, times 8, a to the 10, b to the 2. So when I look at this, I notice I have some numbers. I have 6 and 8. I have some a's. I have a to the 3 and a to the 10. And I have some b's. I have b to the 2 and b to the 5. So I can definitely use exponent laws on the a's, and I can use exponent laws on the b's. But what about the numbers? 6 and 8 do not have a visible exponent, and they are next to a variable, which means they're just coefficients. So I am just going to multiply the 6 and the 8 together. 6 times 8 is 48. And then I'm going to do a's with a's. So I'm going to do a to the 3 with a to the 10. So when you multiply two things with the same base, we add their exponents. So this is going to become a to the 3 plus 10, which is a to the 13. And then for the b's, I have b to the 2 times b to the 5. Because they have the same base, I can use an exponent law for that. So I get b to the power of 2 plus 5. Now, you could put a dot to show that they're being multiplied. You could use brackets around them to show that they're multiplied. But when it's algebra, you actually can just write them side by side and it's okay. So this is 48. A to the 3 plus 10 is 13. And then b to the 2 plus 5 is 7. All right, now it's up to you to just do a little practice.